I know it's stressful. It's stressful on all of us, myself, my TAs, you, because when Thursday's finished with that final exam, then my responsibility is to score. Score and get your score, post it, you'll see your score being posted on Canvas for the final exam, and then Canvas will show the grade. And that's the grade that I'll report, okay? Now, if you want to see your final exam after that, maybe see how you messed up or how well you did, you want to notify me, and we'll make an appointment in the spring semester coming up to get together and you look at your final exam. Okay? Guys, any quick questions before I jump into where I should be? Because we're about to finish the course up. Anything about the last exam? Anything about the exam? Did you guys find that last exam to be a little difficult? Or just what happened? Saw some scores not as strong as they were maybe on some others. Maybe it's the material? Who knows? Now, do we have a quiz this week? I don't think we do. All we have is the final exam to go through. Okay, guys, here's where I am. We're going to start chapter 11 today. And I brought some handouts to help with 11. 11's fairly short but detailed. It'll probably take me today and a little piece of tomorrow to get 11 done. Then chapter 9 is very, 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 very brief. And I can get that done probably also tomorrow, if that's true. And some of this may go into Wednesday. If that's true, though, I'll have a big chunk of Wednesday class time for nothing but review for the final, which I'm hoping that will happen. Okay, so I can start working out some problems with you guys, get you ready for the final on Thursday. So Wednesday, I'm hoping will be a big chunk of time here. Okay, before I jump into it, someone remind me. Philip, I think on the handouts, please remind me. There was one handout that I think I had listed the half angle formulas. Was there a handout that had half angle formulas on it? And guys, what I did on this, and you have it, I did not go through a derivation of where this came from. Usually I derive things. I just gave you the formulas to work with. You say, Professor, my goodness, how many other formulas are there? It could go forever. So half angle formulas, and I've already done the double angle formulas. So I want just to clear everything up before I move into chapter 11. Okay? Can we do law of sines and law of cosines? We did, didn't we? Yeah. Okay. So let me just use this for a second here. And also, I think I better use something that I brought in. Yep. Sure enough. How you guys can do this? Because I was thinking about this over the weekend. I thought, hold on, I don't want to move any further until I get all this cleaned up. Mark one. We list this as double and half angle formulas all together. You guys want to help me out here. Sine double theta. We did that together. In fact, I derived it for you. I'll show you where it came from. Does anyone recall? I know it's a Monday. Does anyone recall what the sine double theta formula looks like? So I'll jot it down. If not, and I know it's on one of the handouts. Is it 2 sine theta cosine theta? Done. And then I think also I had listed when we discussed this, there were formulas for cosine double theta. And I'm gonna start you out with the one that I started out with in class. I think I started out with this one. And then I think I did something with that one to derive two more. Does anyone remember of the two that are missing right now? What's another possibility for a formula for cosine double theta?
The square root.
No, not square root. This is one version of the formula. There's two other versions.
1 minus 2 sine squared.
1 minus 2 sine squared?
Yeah.
You got it. Just in case that version may be better for you in a particular problem. Another version? Does anyone remember what it was? For cosine double theta? And actually, if you know what you're doing here, you can take the original and derive the other two yourself. What's it, guys? You guys who may have your hand out there, was it this one that's missing? 2 cosine squared minus 1? And it all depends on what do you want. Which of those three versions may be most helpful to you in a problem? We did that. Now, tell me, did I do this in class with you? Did I give you a tan double theta? I don't think I did. Is there one out there? There is one out there. I did not give it to you. You could do this though in the attempt to get an answer without deriving another formula. You could place sine over cosine during the tan. I did not give you a secant double theta, cosecant double theta. You still play around with it. The only formulas I gave you were the major ones up here. So I thought I'd point that out to you. And guys, I think we sort of worked with that. Now, the reason I want to do that, and in closing down, so I move into chapter 11, was this. All of a sudden you open up your final exam, and you see something like this. Given, I thought about this as I scored the papers. Given tan theta is equal to 4/3. And a restriction on theta is this. Theta falls between pi and 3 pi over 2. Now, I'm going to find the exact value of this. And my first one is this. Now, please tell me, I think about the exam number 4 you took Friday. Oh boy, I think this was the one similar to what you saw as the last question on the test. I think it was. Where I gave you some information, then you had to fill in the blanks and find sine, cosine, tangent, whatever was missing. Can anyone tell me, looks so much, at least the format, looks so much the same as the last question on the exam. What's the difference? Why am I redoing it? What's the difference in this question? Looks so much like the one on the exam, but there's a difference. What is it? They're asking me to find sine of not theta, like the exam asked you. This one today says find sine double theta.
So this means that we need to find also cosine.
Well, that means you want to go back and use this formula first.
Yes.
Sometimes students will overlook that this one requires a formula. Your exam last Friday did not. I got to use that. And then take my given, and by the way, I think I heard someone say, Professor, if they restrict you to this, you're caught between 180, if those can be expressed in degrees, might be easier. You're caught between 180 and 270. Where are you?
Both negative.
Which quadrant are you? Okay, the third, could you go into the third, it's the third quadrant, called from 180 and 270? Okay. And if I'm there, can you tell me what the signs are there? Are they both negative? Absolutely. Now, sounds much like the last exam. rather than just sine theta, I gotta find this, I gotta find this, and replace it in that formula. Now, who could recall from exam, the last question on the exam Friday, what might I do to find sine theta with what they gave me here? And you guys were saying theta is located in quadrant of what was it, 3? So I know where the angle is located. What would you suggest?
Can we say that 1 minus 10 squared equals to secant squared?
Oh, you want sine squared plus cosine squared is equal to 1?
Yes.
And that's what you were trying to do on that exam last week, to find something here. If I gave you tangent,
Oh, hypotenuse.
you better choose another property. I don't think sine over cosine is equal to tan is gonna work here.
It's secant.
Well, I heard what, 1 plus tan squared is equal to what?
Secant.
Secant squared, so on the side here. And they gave me tan is 4/3. I'll make my replacement. May help me. You guys, if I put this together, that's 1 plus, and I'm going to do the arithmetic and not mess up, I hope. 1 plus 16 over 9, is it? Is that going to be 25 over 9? Altogether? Which is nice if that's the end, because you're going to do a perfect square root. What is that, 5/3? Secant. Now in quadrant, which one? Quadrant 3, so secant should be what, negative?
It means that cosine is.
There you go. Cosine immediately should be what? Negative what, 3/5?
Yes.
Reciprocal.
Which also means that sine is 4/5.
There you go. You guys follow the logic here? This requires a little bit of work here, much like the last question on the exam, that's why I brought this in this morning. But they're asking for double theta. Now let's see what I can do here. Go back to my formula, and cosine theta, we just found that, we put it right here, this is negative 3/5. Now, I need sine, I think the student already told me the value for sine.
Yes.
He's using, what, sine squared plus cosine squared.
We also can use just the tangent.
You could, yeah. We also know that is a property. Cosine is negative 3/5. And we put that in easily. And I think he gave me the answer earlier. Let's see if I get that same number. I think I heard him say, sine squared theta is going to be equal to, we're going to do the math here. That's 9 over 25, move that over, subtract it. 16 over 25. Do a square root, which is perfect. 4/5.
Negative.
And it's negative, see, all these little things you gotta watch out for. It's negative because we're in quadrant 3. There's another replacement. You'll say, Professor, put that in right here. And then of course 2 out front in the formula. It took all that to find sine double theta. Final answer? It'll be a positive. Looks like it might be 24 over 25.
Yes.
So don't be misled if on the final exam on Thursday you're sitting there taking the test, and all of a sudden on the question it says find sine double theta, not find sine theta like you did on the last exam. If it does say double theta, you got to come up with the formula. And I thought I'd bring this in just to show you. This right here is the key, if you see that right there. The 2, that's going to require a formula. PK, if you see a 3, I did not give you any triple angle formulas. Now, do I have some students here in class, quite a few students, who could actually derive a triple angle formula? Yes. They could derive their own if they needed. Okay? With me, guys? Marina? I'm not going to do cosine double theta. I could on the same problem. If I were to find cosine double theta, then I have to go back to and decide which one of these I want to use. Sometimes it makes no difference which version, and go through the same routine. Okay? If I ask you to find tan double theta, then you should find what this answer was, this, over cosine double theta. And you would tangent. Making sense, guys? Lord, I don't want to sit down Friday and start scoring final exams, not with the class that's worked as hard as you guys have, and see students messing up. I don't want to see it. Okay, so I'm gonna be here for you. My TAs are always here for you. In fact, Mr. Park's gonna do a little lesson, he's gonna be a professor for a while tomorrow. Got something planned. So we're here for you. Now, what you do on the outside is a different story. So here, me and my TAs will be right here working with students to get ready for that final exam. By the way, how many points is that final exam worth?
150.
150, that's like 150. You can't mess up on that. Got any concerns here? At all? Now, before I get into the half angle formulas, just to close everything down before I start chapter 11, I did also do this. I thought it would be wise to bring it in. Find the exact value of this. And it looks like this. Nice. But I'm closing all this down. I'm closing the trig down. Looks like that. Let me give you a hint. If this 2 was missing, I'll come back and put it in. That would be old work for us. Is that true, guys? Have we done something like this? Cosine, in this case, cosine inverse sine of 3/5. Could we do that as we did in the past? Didn't we? Absolutely. Now, what effect is this going to have on what I want?
Makes double angle.
It's a double angle formula.
Of course.
It's 2 times. That's why I'm doing this. So that means you want the answer here, you want to go to cosine double theta, and you say, Professor, you have a choice. Well, try one of these. And you might find one of these 3 to be more appropriate. It's up to you to get the answer. But I gotta go and choose one of those 3. Now, what do I know at this point, though? I do know this is involved. Can someone give me a description of inverse sine 3/5?
Sine equals to 350.
Okay, there's an angle out there whose sine is, it's called theta, is 3/5. And since I see that inverse notation, they've restricted me. You gotta know those restricted intervals. Who remembers a restricted interval for inverse sine? It's gotta be located where? We had that in class. Where is it? For inverse sine, does anyone recall the restricted interval? Oh my goodness.
-1.
The interval on the unit circle.
2 pi.
Which angle is it? Is it called between 0 and pi? Pi and 2 pi? Pi and 3 pi?
-pi/2 and pi/2.
And was it bracket?
Yes.
Thank you. It says you're either in quadrant 1 or quadrant 4. You're caught between -90 and a +90. Well, we lucked out here. Just a little recap here. Since it's a +3/5, guys, I'm in quadrant 1. Everybody loves being in quadrant 1. So this will take place in quadrant 1. Now what you could do in quadrant 1, you know the sine is 3/5. Could I find cosine if I need it? I have sine to be 3/5. Is there a way to find cosine right quickly?
4/5.
Okay, I'm here in 4/5. What, sine squared plus cosine squared must be equal to 1. We'll use that identity. Here we go. And we'll show all the work. And I know sine is 3/5. Put that in. This. Guys, we do this arithmetic fairly quickly. Watch it, do not let me make a mistake. That's 9/25 when I square it. Move that over. I think you end up, what, 16 over 25. Do a square root, nice and perfect. 4/5. That should be positive. We're in quadrant 1. That's cute. Now I know this. You gotta keep in mind though, we're looking for double. Eventually. Now, do I have enough now at this point to go to one of these double angle formulas for cosine and make a replacement and get an answer? And I don't care which version you use. Do we have enough over there now to go to one of these versions? If I try that first version, Philip, it says this, cosine squared, if you want to use that version, this is equal to 1. I think we're 1. I'm ahead of myself. Cosine squared minus sine squared is the formula. Now, do I have enough to put in there? Well, cosine looks like it's 4/5 that we just discovered. And sine, I think, was 3/5. Let me step back and see if you guys agree. Finally, I got what, 16 subtract 9, what is that, 7? So 7/25? And there's your final answer for this.
Can you use the other formula?
What's that? Absolutely, you could use one of the other formulas, you get the same answer. I used my first version, cosine squared minus sine squared. Okay, June, do me a favor. Just to confirm something here. Would you go ahead and find what inverse sine 3/5 in degrees is? What angle are they talking about?
Um,
36.87.
8/7, okay. Now, hang on, 8/7. June, please do me a favor, double that, it says double this. Now that becomes what?
73.73.
7/3? This is in degrees. Now find cosine of that 73.73. Let's see what the calculator shows.
0.28.
0.28? Now guys, we got this answer. See what 7 divided by 25 is. Is it 0.28? Check. 7 divided by 25, I hope.
Yeah, so it's.
So it checks. Okay. I'm sensing nervousness, anxiety. Look at my students are looking to, I don't know if this is gloomy weather. I don't know. I think they're predicting gloomier weather this week, aren't they? I wish let's get some really heavy rain soon. Oh. Okay. Guys, any concerns here? Okay. Now, if I make a mistake, I'm a little tired, I'm constructing my test, and, Karina, somehow, I didn't watch carefully, and I put a 3 there. Oh. Oh, I didn't catch it myself, saying, no, unless I gave that for an extra credit, because that would be a triple angle formula. And you don't see any triple angle formulas being listed, but you're not really required to know, okay? So I gotta be very careful here. Guys, we're okay here? Good? Okay. Philip, I'm taking your handout you gave me here shortly. Hang on. We got that one done. June confirmed it. Now, last thing I want to do here, and then we're going to take a look at this new material here. I want to do this. Solve the equation. Solve. Let me just make it real quickly on this integral. Yes. Like the textbook did. And that. Solve on that integral, and the equation looks like this. And then I'll stop and start closing this down. Okay. Guys, any ideas? what's going on here? Yes.
I think we did this one like 2 days ago.
Oh, did we?
Yeah.
I need to, oh, phew. And we're gonna redo it. Thank you so much, though. But I'm putting this down. Any ideas with what we're doing here? We started out with these formulas. Now, does anyone see something there that may alert me to maybe I should go to one of those formulas?
So theta equals to 1 half.
Yeah, that's why I was saying, well, first I sine double theta. Is there a formula for it? I see that 2 there, so I cannot do anything until I recognize this.
It's 1 half.
This formula. You go to the formula in. Does it say sine double theta back there? And you can't do anything with it unless you know the formula. So I gotta put the formula in right quickly. As that, and yet equal to that. You're going nowhere unless you know those formulas. Now, if you tell me I worked this earlier, are you saying I worked this earlier?
Yes.
Okay. Can you now tell me what might be wise for us to do as a student to finish up?
Set that sign.
Set it equals 0, so move the cosine.
You got set equals 0, which means you're gonna do what? Move this over? And rewrite as 2 sine theta, cosine theta, moved over, and finally get your 0 that you need. Gotta pay special attention to this because I'm closing down. PK, any idea of what to do with that equation? Not to put you on the spot there, just look at it. What might you do with that expression? There you go. And what about it? Take it out. Take cosine theta out. Common factor, she's right. That's going to leave this. Minus 1 of all things on the end. There's my common factor taken out. Split this up. You know the routine now. You're going to say cosine theta equal to 0, which I'll come back to. And you're going to set this equal to 0. Now, let's go ahead and solve this one. I think I heard a student tell me earlier. This is sine is 1/2. We can actually solve it. Move the 1 over, divide by 2. And of course, this is in good shape right now. Now, all I'm asking you to do on the final exam, makes me feel good when you do this at this point. Where is cosine, the x-coordinate, equal to 0 on that unit circle? And the answer you give me must be caught between 0 and 360. Anyone recognize
Pi over 2.
pi over 2?
And 3 pi over 2.
There you go. And 3 pi over 2. The x-coordinate, cosine for both those is 0. This one says now find those where the y-coordinate, sine, is 1/2 on that unit circle. And again, you're caught in this interval. Does anyone recognize that?
Pi over 6.
Pi over 6, and I think there's another one.
Pi over 6.
Pi over 6. And you've solved the equation. It's finished. You now have 4 answers. I think we said pi over 2, 3 pi over 2, pi over 6, pi over 6. And those are the answers. Whoa. What a way to greet you on Monday morning. Monday afternoon. Gee, Ramsey. What are you doing? Okay, guys, take a close look. I'm leaving this. And then I'm going to mention the half angle formulas. Guys, any concerns here? A little recap. Okay, to me. Now he says, you guys have where I had the triangles drawn for you. You have this now. And all I have mentioned to close down the trick part of the course, all I have to mention here are, there are a couple of formulas called half angle formulas. Formula after formula after formula. Professor, may I use a formula sheet? Are you gonna let me write all the formulas down on a sheet of paper, bring it with me? Or will you have all this typed up nicely for me, give it to me as a resource, as I'm taking the final exam? You think I am? No. So however you recognize or remember this, it's up to you, how you remember all this. Okay? Guys, let me get this half angle formula out of the way. And then we're finished with all this. This looks a little scary. It looks a little scary here to do all this. And this is just the tree. Closure. Anyone watch the game yesterday? Super Bowl? Anyone watch it? Yeah. I was watching myself, and sure enough, remember the student I told you, she's an actress now? Yeah, I told you I taught her. And I saw her picture on a billboard on, Santa Monica Boulevard, one of those, Sunset probably. Driving through, and I looked at her and I said, I know her. Very nice her. She's an actress. And she had one of the commercials yesterday. Super Bowl. I saw her. I don't think she's thinking about double angles anymore. Guys, let me leave that there. Okay, Philip, I know I have your hand out. All I want to mention is, closing down, these now will feel good. Let the tree be closed down. Guys, you know me, I like to derive and show you where things came from, but these I will just directly give them to you. Sign of Joseph, look at this. Are you kidding? Ramsey, you did double, there was a 2 there earlier, now there's a 1/2. Could there be a 1/4? And later on in grad school, there could be a 1/4 theta. So right now we got double, this is a half angle formula, that's all we need to work with, those two. And your formula on the sheet here says, it should be plus or minus, square root, and looks like this, sine. 1 subtract cosine theta all over 2. And the other one, I need to use it, cosine half angle plus or minus square root, and this one's 1 plus cosine theta over 2. So guys, if you memorize, I hate to use that word memorize, but if you memorize or know one, you'll know the other. So those are the only 2 half angle formulas I'm going to ask you to please know in case you need them. Is there a tan? I'm sure there's a tan half angle formula out there, but if you have enough right here, you can put sine over cosine and do it yourself to find tan. So we're going to just deal with those 2 there. Now how am I going to deal with it? Very brief. Looks like this. Find the exact value for this. Cosine of pi over 12. Does anyone can someone convert that to degrees real quickly for me? What is pi over 12? Just out of curiosity. Change into degrees.
That's 15 degrees?
Is it 15?
I think so.
Now, if it is 15, I think it is 15 degrees. You may say, Professor, if you say 15 degrees, could I not go back to something we had in the past and think of this as, here guys, this, subtract this, think that's, pi over four. Yeah. Subtract this. I'm just trying to turn around here. Was this 45 degrees here? In degrees. Pi over four, when I say pi over 45, subtract what? 30? Is that the 15 we're talking about here? So I mean, if I ask you to find cosine of 15 degrees, you say, Professor, why not use that? In other words, we've done this. This fits the formula what? A subtract B. This way I'm closing down. Is that true? So if I didn't tell you how to do it, you said, wait now, I'm gonna find it by using cosine A minus B. 15 degrees. Now, does anyone recall what the cosine A minus B from way back formula looks like? Oh, you gotta know your formulas. I know it's pretty tempting to bring a little sheet here with all those formulas listed. You know you can't do that in here. Cosine A. Any more cosine B? Okay. Plus. Sine A. Sine B. You gotta know your formulas. Now, here's the problem on this. I need to come up with all these values here. Guys, cosine A, looks like A is pi over 4. So this is cosine pi over 4. Next to it, cosine B looks like B is pi over 6. And then plus sine pi over 4. Sine pi over 6. Just make sure I put all that in correctly. I think it did. Now, all those could be recognized from the unit circle. Guys, cosine pi over 4, we all know that. Radical 2 over 2. Does anyone recall what cosine pi over 6 was? Radical 3 over 2. Does anyone recall what sine of pi over 4 was? Radical 2 over 2. I know this. And finally, sine of pi over 6, 1/2. If you do all your business here, which I think we've done in the past, this is radical 6 plus radical 2, all of what? 4. I guarantee you, I'm not going to ask June to do this for me. I guarantee you, if she should approximate this, and then we go back and find cosine of 15 degrees, I bet it's the answer. Now, why did I bring this in, Professor? I thought you were talking about half angle formulas. Give me another approach I could have taken to find cosine 15 degrees, pi over 12, and not have done it like this. Is there another approach?
So 1 minus pi over 6 divided by 2.
Well, all right, am I going to half angle formula?
Yes.
Okay, first let's do this. Cosine of, now see your hand going up, half of what?
Pi over 6.
Thank you. Half of 30. That's pi over 12. Now you've made it look like this. Therefore, I can redo the problem and use this form, half angle formula, which might be a little bit shorter to do it this way than with the A minus B formula. Guys can do this as plus or minus. By the way, we're doing 15 degrees, so I know it's in quadrant 1, so it's going to be a positive here.
It's the lower form.
The lower one here, positive. So it's going to be square root of 1 plus cosine what? Pi over 6 all over 2. Let me step back and see if you guys agree. Is it true, guys? Let's crunch this out. And I know it's going to look a little strange. Here goes 1 plus cosine of pi over 6. In fact, that's strange also. Radical 3 over 2. All over 2. Bring this up further. Let's put these two together with the common denominator of 2. And you get this. Look at this mess. Over 2, all over 2, and all that's underneath that large square root.
It's just square 2 plus square 3.
Well, let's do this though. Let's just jump out. I'll show you all the work here. So this is the square root of 2 plus, what was it, radical 3? Is that all over 4 now? Is this equivalent to this?
Yes.
Woo! Now to finish this up, here we go. If I do the square root of the numerator, not much I can do there. It looks strange as you know what. It looks like this. But when I reach the denominator, that's a nice perfect square root, 2. Now here's the issue. Suppose Ramsey does not tell me which formula to use. And I'm scoring papers. And Joseph has done this problem this way, and the answer looks like this. Selena, on the other hand, says, Professor, I did it with a half angle formula, and I got this. And I'm scoring papers. Now look how different these answers look. And when I asked June to maybe calculate real quickly those two, they're equivalent.
So we can solve by the same.
Hey, exactly, but I don't say which way to do it. You may solve by what the A subtract B formula, and get this for an answer, and then other students say, no, I want to use a half angle formula. We did here, you got this answer. Now I gotta be careful when I score paper because this answer looks so different from this one. June, do me a favor, please. Would you just calculate what this is right here? Radical 6 plus radical 2, that quantity divided by 4. Tell me what that's close to. Just out of curiosity.
It's 0.97.
9.7. Now, I'm so glad I have her to work with me here. Now, be careful here. Approximate this. This looks so different than what she's doing.
It's also 0.97.
0.97. Looks like no way could those be the same. They look so different, don't they? Absolutely. But they're the same. Our guy's tree is close. Any concerns here? I feel good about this. Your professor has left out nothing. So when you move to Math 7, you should have it all available for Math 7. Any concerns here? Close it down. Close it down here. Now, I will say, and I feel for you, I will say sometimes on the exam itself, I might jot down the formula on the side. I may say find cosine of this, and on the side I'll say use this formula. Sometimes I'll do that. But know your formulas, for sure, just in case. Now we're going to start chapter 11. And you talk about a relief. Chapter 11. Completely different topic. Completely different topic. Okay, guys. We're ready? I think we're ready. Let me get you started first. So I have brought in. Here we go. And then I think, if I'm right. Oh my goodness, here it is. Okay, here it is.